vector, summation, and calculus, integral calculus. Okay, so we are pursuing discussion in vector, summation, and integral calculus. And more or less, knowingly, unknowingly, we landed up in something called dy by dt equal to cy plus s. Actually, the differential equation is dy by dt equal to cy plus s. That is the differential equation. We are taking this as a measurement. We are taking this as a there are real case study. We are mapping this differential equation into real life, and one real life scenario can be y can be a bank balance of one account. Someone has opened an account in a bank, and y is the bank balance at any moment. Y is the bank balance dy by dt, change in the bank balance, that is also called interest. If someone has deposited money in the bank and at any moment he is seeing the amount that is in bank in his account and it is y, after some time he is going to the bank again after delta t time. After delta t time, he is going to the bank again and he is seeing another amount that is y1. Earlier it was y, now it is y1. Y1 is the current y. How much difference he is seeing? Delta y. Delta y is y1 minus y. Or if someone has seen the account balance as y1, after delta t time he is going to the bank and he is seeing account balance as y2. There is a difference in the account balance and it is y2 minus y1 called delta y. Delta y by delta t. In delta t time, delta y change in the amount that is seen in the account. This can be said that per unit time, the change in the amount in the account is seen as delta y by delta. Per delta t time, delta y is the amount, that is seen in the bank account. Per delta t time, delta y is the amount. Per unit time, delta y by delta t, this is per unit time, is the amount, change in the amount seen in the bank account. Okay, per unit time can be year. That is the case of the bank. Many people they say 6 months also. Depends upon the scheme. Many people say that your money will be your principal amount. If someone has principal amount will be added to interest and new amount will become, I'm sorry, if someone has deposited a Y0 amount at times T0, Y0 amount in his scheme, after 6 months, delta Y is the interest that he is seeing. So Y0 plus delta Y will become new principal after 6 months only. And then interest rate, whatever the interest rate C is, that will be applied on Y0 plus delta Y. And after 6 months again, whatever the new delta y is, the delta y will get added to the earlier y0 plus delta y. Whatever it comes, then C will be applied. So some bank they give this kind of scheme also. Means your principal amount will be updated every 6 months or every year, depend upon the scheme. Okay, if I say it is every year, then dy by dt equal to cy plus s. Actually, this is pure. No, no, no. This is related to bank. Certainly not. This is not only related to bank. It can be related to many other things. One example I have given that it is related to bank, where y is the current amount in the account. Someone goes to bank, he has taken one scheme, and sometime he is seeing amount in the bank is y. After some time he is saying there is delta y change in the amount over period of delta t. Delta t is in years. Okay, then he can say over delta t, change in the amount happened is delta y. Someone can say delta y is your interest in amount it incurred in the duration delta t at any time t. Then what is per unit time? Then delta y by delta t. If per unit time delta t tends to 0, the delta y by delta t will become dy by dt. Means per unit time, which is year, per unit time, how much the interest someone is getting, that is delta y by delta t. Per delta t time, how much interest someone is getting, delta y. Makes sense? These are two different things. Per delta t time duration, how much interest bank is giving, delta y. Per unit time, how much interest bank is giving, delta y by delta t. Both are different. Anyway, that is the interest someone is getting. So delta y by delta t is the interest someone is getting per unit time. If I take per unit time as 1 year, someone can take per unit time as 6 months, per unit time as 1 month, per unit time equal to C into Y. C is a constant, that is also called interest rate. It's a constant into Y. Y is the current amount. Whatever the current amount is, on top of it, interest rate will be applied. And current amount, they will show like current amount is getting modified every microsecond. Every microsecond, current amount is getting modified. Not after 1 year. This is what the new technology is coming like that. So bank, they are showing two kind of interest. One is the interest that someone would get. It will be written on top of it. 5% annual interest you will get, recurrent interest. But again, I personally see, then again now they will write 1 year, 2 year, 3 year, 4 year, 5 year, 6 year, 7 year, 8 year, 9 year, 10 year. Then right side they will write effective interest. 5% is the annual interest, effective interest, that they will write. What is effective interest? At the end of 1 year, effective interest will be 5.33%. At the end of 2 years, the effective interest will be 6 point something, 7 point something, 8 point something, like that. So at the thing that will be marked here, at the end of 1 year, it should be 5%, but it will not be 5%. It will be 5.33% or something like that. Means C is 5%, dy by dt equal to C. C is 5% annual interest. But Y, the Y is not Y0. That is the beginning amount. Y is any moment, what is that Y? So it is not like that every year they are going to update the principal amount. Every moment principal amount is getting updated. This is called continuous updation of the principal amount provided C is the interest rate per year. This is, looks like little bit cumbersome, but this is how it is. Plus S. S is the amount someone is depositing. See the unit of S, dy by dt. Change in the Y means interest, that is the interest that is bank is giving per year, or bank is taking per year. Someone has taken loan, then bank is taking interest per year, or someone has deposited money in the bank, then bank is giving interest per year, dy by dt, where dt is 1 year. Every year, how much is the bank is giving interest, dy by dt, equal to C into Y, dependent upon what is the current money in the account. Current money keep on changing every second, every microsecond. C is the fixed interest rate per year. So dy by dt is amount per year. Y is amount. T is time. Amount per year. C is percentage. 5%, 10%, something like that. Y is amount. This proves that C into Y is amount per year, as per the fundamental. Plus S. S is amount per year. Means what is S? S is someone is depositing that much amount every year from extra, outside. This is called outside money. C is called constant and Y is called the current money coming from inside. S is coming from outside. What is inside and what is outside? C is called growth factor. In electronics term, C is called growth factor. Growth factor from inside. From inside. And Y is the, right now, what is the amount? C is inside growth factor. Someone is inside. Okay. Mean from stomach and then heart and then eye and then brain. From inside. There is, I'm not kidding it. This is how it is written in the book. From inside, growth rate is C. So dy by dt equal to C into Y plus S. S is a source from outside. What is outside? I deposited money in the bank thinking that every year it will give recurring interest. Means every year the principal amount will change every year and it will become more, and C interest rate will be applied on new principal amount, but it is happening continuously, not at the end of 1 year. This is what I was thinking. But at the end of 1 year, when I went to see my money, I was surprised to see that money is much more than I was expecting. I was expecting C into Y as the extra money. C is interest rate and Y is the amount. So on top of amount, if I multiply the interest rate, that is the interest I am expecting at the end of 1 year. But I am seeing bigger, much bigger money than interest what I was thinking. This proves that there is external money that is coming inside the scheme. Someone is depositing from outside. Over 1 year period, I would say over 1 year period, someone has deposited S amount, or in a one go, or what say. Over 1 year of the period, someone has deposited S amount of money from outside. Then next year, again for 1 year, because interest rate C is per year. Over the next 1 year, someone is depositing amount S from outside, which is S is constant. Next 1 over year, someone is depositing amount S from outside. Okay, then I am seeing as whatever interest I was expecting, there is an extra amount called S. Okay, now if that is the case, then what is the money I can expect any moment? I want math. I am completely perplexed by this kind of scenario. I don't want S, but someone is very well wished to me, and he is keep on depositing money in my account. Okay, so constantly S amount he is depositing in my account every year. He is well wisher of me. So at the end of year, instead of seeing some interest, I am seeing more in interest. Now formula become dy by dt. The interest that I see per year equal to interest rate into y. What is the amount deposited at that moment? Plus s, which is added from outside. Is it the only explanation of the this is very famous differential equation. Why this is famous? Because rate of change is dependent upon the money deposited out there. Dy by dt, change in y is dependent upon y. That's why C is called growth factor from inside. From inside. I'll talk about inside. Okay, this is very famous differential equation, because this is the beginning of multi-dimensional differential equation. What is multi-dimensional differential? d2y by dt square, double differentiation of y, d2y by dt square plus a d2y by dt square plus b dy by dt plus c equal to d. Okay, a d3y by dt square plus b d2y by dt square plus c dy by dt plus d equal to e. This equation is the starting point of multi differential equation. Okay, that's why it is very important. Anyway, can you tell me any real life example of this example? Yes, certainly. Consider I have a battery. I really have I have a battery. I don't know where the battery went. I have inductor and everything. Oh, I really had an inductor. Where that went? Okay, I had a battery, that also where it went. Okay, I really had an inductor, but I don't know where it went. Okay, I have a set of very powerful battery. I have a set of very powerful battery. Okay, there are many battery attached to it, and this battery has, oh, now this battery has this side as cathode and this side as anode and this side cathode. This is a set of battery. There are few there are few capacitors are there. I had one more where inductor was also there. Now consider this battery is connected to a resistor. This is a battery and very powerful. If I by mistake also touch the negative and positive, it will make the room full with the smoke. That much powerful it is. It is lithium ion. Okay, I'll connect this negative and positive. Positive side of the battery will go to a resistor and resistor will go to an inductor. I had one very good inductor, and inductor will connect back to the battery, negative side of the battery. Makes sense? This is positive side of the battery. Positive side of the battery will go to a resistor R, then it will pass through an inductor L, and then it will come back to the negative side of the battery. This is called LR circuit, inductor resistance circuit. What is the current formula for it? Consider what is if I current is flowing through the circuit. I is constant, certainly not. I will keep varying. Okay, if someone is attaching battery to the LR circuit immediately, then it will stop the current. Inductor will forcibly, internal inductor will develop a magnetic field where it will oppose the flow of the current. Like the capacitor, it opposes the potential difference. Potential difference. It will show like a shunt. If I attach a capacitor instead of inductor, then it will behave like a wire. There is no resistance at all, and current will flow. After some time, it will start developing a potential difference and current will stop. Inductor, if I place, immediately it will oppose the voltage drop across the capacitor will be high. Opposite to the voltage drop across the inductor will be extremely high, infinite. It will provide infinite resistance to the current. Current will not flow at all. Then after that, that electromagnetic wave that is generated around the inductor, which is opposing the flow of the current, okay, it will start diminishing. Means the kind of and after some time, the inductor will behave as a wire. Current will flow completely. Okay, meanwhile, in the transient phase, when current is not flowing at the beginning and current is flowing at full pace, that what is the transient current at any moment? What is the transient current? What is the voltage difference? Then if I add all three voltages, battery voltage, voltage across resistor, and voltage across inductor, if I add in a loop, it should be zero. If I say my voltage source is Vs, then Vs equal to I into R, where I is momentarily current. Any moment current is I. I into R plus plus L. L is the inductance of the capacitor. I believe it is in Henry. L. L is the inductance of capacitor, that is the constant nature of the capacitor. L di by dt. The voltage drop across inductor is how quickly current is changing over the time. If di by dt is very fast, then it will generate more voltage across the capacitor. Okay, in the maturity case, when it will be mature, then di by dt will be zero because there is no change in the current will be seen, and voltage drop across the inductor will be zero. At the beginning, when current is zero, then in voltage drop across inductor will be very high. This proves that di by dt is very high at the beginning. What I am saying is, this is a battery. Battery is connected to a resistor. Resistor is connected to inductor, and inductor is connected back to the battery. Okay, in that fashion, if I switch on this battery, or if I place a switch and switch it on, then immediately there won't be any current in this loop because there will be a high voltage difference that will be generated across the inductor, and it will oppose the flow of the current, or there will be electromagnetic field that will be established across the inductor and it will oppose the flow of the current. What is the voltage across inductor? When in the circuit current is I, then it is L di by dt. How much current is changing per unit time? If di by dt is very high, that will be seen at the beginning. Then voltage drop across the inductor will be high. Okay, in that fashion, it will oppose flow of the current. But slowly, the voltage drop across the inductor will start dropping. Means di by dt will start slowing down. After some time, di by dt will be 0, means there won't be any change in current that will be seen against the time. This proves that current will become 0. Current will start flowing as if it is flowing through a naked wire. What is the transient current and time relationship? If someone sees the voltage, if I say voltage source is Vs, S means source, Vs, someone can write it as S also. S equal to R into I plus L di by dt. Makes sense? I'll take out L here. It will become di by dt equal to minus R by Li plus S. Makes sense? Hope plus S by L di by dt equal to minus R by L I plus S by L. Is it not the same what we are talking dy by dt equal to Cy plus S? Here di by dt equal to minus R by L. Minus R by L is C. C can be negative, certainly C can be negative. The interest rate can be negative. What do you mean? If interest rate is negative, if I deposit any amount, then amount will start decreasing. If interest rate is positive in a bank, then amount will start increasing. So here interest rate is negative, minus R by L into I plus S. S is S by L, that is a constant. S by, what do you mean? di by dt, change in current per unit change in time. What time you are taking? I am taking second. It is up to anyone. What time unit he wants to take? Per second. So per second, what is the current that is changing per second? di by dt. Okay, in that sense, minus R by L into I. I is current. Then minus R by L would be per second as per the fundament, equal to S by L. This proves S is a voltage and L is inductor. But if someone take it, it will become current per second only. Okay, voltage by inductor, if someone solve it, it will become current per second only. Means this is called outside voltage. S by L is called outsider. What is outside? If I have a inductor and resistor, if I consider this as the internal circuit, then there is an outside voltage source is there, that is S. So S is called outsider. It is providing voltage from outside. Someone is depositing money in my account from outside. Someone is giving you voltage or current from outside. Current, di by dt, current I. Someone is giving I per second from outside, that is S by L. Okay, I have interest rate that is negative, means current will start decreasing. Oh, I'm sorry, di by dt equal to minus R by L, I plus S by L. Means okay, I should start increasing. Anyway, it will change. For timing we can take, it will change. Current will change. The way amount in the bank account is changing, current here also it is changing. What is the beginning current? There, what was the beginning amount? Beginning amount was Y0. What is beginning current here? 0. There is no current at the beginning. Okay, what is the formula someone brought earlier? I remember it was Y equal to C e to the, Y equal to Y0 e to the power Ct plus S by C in bracket e to the power Ct minus 1. This is what I remember we brought in a formula. Here C equal to minus R by L. Okay, and S equal to S by L. Someone say I equal to I0 e to the power C e to, there it was Ct. Here it will be e to the power Ct. C is minus R by L. I0 e to the power minus R by L into T. This will be a formula here. Okay, plus S by C. S here is voltage by L. Voltage by L. And what about C? C is minus R by L. Okay, it will be voltage by R. I think so. Minus voltage by R. Minus that will be the steady current. V by R will be a steady current. The current at the, after once it becomes steady whatsoever. Then e to the power minus it is. Now someone can make it minus 1. This will be the formula. Where I0 we are saying it is 0. So first term will go away. This is what I think. So someone can try. First term will go away because I0 is 0. At the beginning there won't be any current at all. Then someone can solve it. What I am trying to say is dy by dt equal to cy plus s has a larger implication what we are thinking in terms of banking sector only. It is useful in other sector also. There is a temperature formula from Isaac Newton, Sir Isaac Newton. There is a temperature formula. If if I have a temperature body, consider this is very hot, very hot, and temperature is Y now. Consider this is very hot and temperature is Y now. The room temperature is Y infinite. What is Y infinite? Means that is a steady temperature, ambient temperature. Or I can say, but this is a formula is dy by dt equal to constant and in bracket Y minus Y infinity. If I have an entity whose temperature is Y at right now temperature is Y, okay, or temperature is Y, or what is the temperature? Consider this is a very hot body, and this hot body is slowly it is cooling down because ambient temperature is lower than this, so it will cool down. At any time, what temperature I see here? Consider any moment I see temperature as Y. Then dy by dt at that time when temperature is Y, at that time at what rate per second temperature is going down? Dy by dt equal to c, some constant, and in bracket Y. At that time what the temperature minus Y infinite. Y infinite means after infinite time what will be the temperature? That is the room temperature. This is Newton formula. So dy by dt equal to, if I break it, it becomes cy minus c into y infinity. Dy by dt equal to cy. That is exactly what in the bank we took, cy minus cy infinity, where c is constant, y infinity, that is ambient temperature is constant. That is the external. So when we see external, dy by dt equal to y plus s, where s is external. External means external temperature. If I talk about the LR circuit, inductor resistance circuit, then external means external voltage source. That is giving the voltage or current from the externally. Cy, growth factor from inside, because the change in the current di by dt, di by dt is a change in the current in the inductor that is dependent upon the current that is flowing through the inductor. Means inside it, whatever the current is, the change in the current is dependent upon inside it only. Makes sense? Okay. How much angry I am, it depends at what rate I am gaining the angerness. Someone is becoming, I am becoming very angry. Although I never become angry. Consider I am becoming angry. At what rate my angerness is growing? It depends upon at what level my angerness is. Means something that is my rate of becoming angry is dependent upon how much angry I am. Means the rate is dependent upon inside only. Dy by dt equal to cy. Dy by dt is dependent upon y only. So c is called growth constant. At what rate it will grow? You are dependent upon your inside. That's why it is called internal growth rate. Plus s. S is called external factor. Anyway. Now can someone calculate this dy by dt equal to cy plus s from other mean? What do you mean by other mean? One mean you told that itself is undigestible. Okay. What proof we gave to calculate dy by dt equal to cy plus s? The proof we gave, let's take s equal to 0. There is no external factor. Then dy by dt equal to cy. Then ln y equal to ct plus k, if someone goes with the integration. Then y equal to e to the power ct plus k. Y equal to e exponential e to the power in bracket ct plus k. K is a constant. Okay, if someone breaks down y equal to e to the power k into e to the power ct, how to find e to the power k? Let's take t equal to 0. When t equal to 0, y is y0. If I take example of bank account, Then what is the amount that is in bank at the beginning? Means how much I deposit. That is called y0. y0 equal to e to the power k. Now I can replace it as y equal to y0 e to the power ct. This proves that whatever I am depositing, it is growing through e to the power ct. Whatever I am calculating through this equation, it will start growing. What it will start growing? Okay, if I say whatever I am depositing in the account, it will start growing by factor 2. Factor 2 means if this is x-axis and at the beginning I had deposited this much account, this much money. This much money I deposit at the beginning. Now this money is growing. After some time money is this. After some time money is this. This is the time. And vertical is money. At the beginning I deposited this much money. After some time this is this. After some time this is this. After some time this is this. This is growing. Okay, this is growing with the rate of e to the power ct. That is the multiplying factor I am seeing. When t equal to 0, then I have y0. When t equal to 1, then it is y0 into e to the power c into 1. Now I can just plainly calculate it. No need to that it will become after 1 year principal amount will become like this and then I start calculating. Nothing is required. Y equal to y0 into ct. Amount that is at the beginning, it will start growing through a multiplying factor by e to the power ct. As per the equation dy by dt equal to cy. Means in this equation, if someone is depositing S amount of money every year, that money will also grow S into e to the power ct. Whatever money, it is something like there is a pipe which is taking a liquid or there is a river where water is flowing. Okay, if you put anything, if you drop a bucket of water in the river, it will start flowing in the same direction as if water is coming from the origin of the river. It is like the if I have a scheme that is going, if I have a scheme where the amount is growing with the multiplying factor e to the power yt, if someone is dropping money inside that stream, it will again start multiplying by e to the power ct. If I am dropping someone is money in this scheme, after some time, again it will start growing e to the power ct, where S amount is being deposited in the account per year. I was saying at the end of 1 year. During the year also someone can deposit. During 1 year time period, someone has deposited S amount and that is constant every year. It is not changing. The way battery voltage source is constant, it is not changing. Okay, in that fashion, how we calculate it? In that fashion, if I say, if this is the first year, 0 year, first year. During the first year, someone is depositing amount at S. Okay, this S. Then second year, someone is depositing amount at S. Third year, someone is depositing external amount at S. Fourth year, fifth year, sixth year. Consider I am trying to calculate the net amount at the end of 20 years. 20 years. Then the first amount what we are putting, it will go for 20 years. If something different I said, you can mix it like this. The first amount I deposited, it will go or if after some time period capital T. Consider this axis is capital T, no small t. Small t is the time that is 20 years. Okay, there is a time called capital T. In the first t equal to capital T equal to 0 and capital T equal to 1. During this period, I am depositing an amount called S. Then S will become S into e to the power c and t. T is the duration that it is going on. I had deposited at time t from the beginning. So it will be t minus capital T. If this is n, consider I am depositing for n years. Then this will means whatever money I am depositing, it will get matured after n year, 20 years. This is the beginning. Between 0 and 1 year, somewhere I am depositing S amount. This is at capital T distance from the beginning. There is n, 1, 2, 3, 4, 5, 6, 7, 8, n. There is a capital T that is going from 0 to onward. After capital T time, that is less than 1, I deposited S amount. This S amount will go for S amount, what it will become after n years of time period, where n is from beginning, where I took capital T time to deposit the money. Then it will be S into e to the power c and in bracket 20 minus capital T, because that much less duration it will expand. The expansion time of this money will be full n years minus the capital T time I took. Now let's take another one. Let's take another one. Let's take another one. Now keep add it. What to add now? That add is S. So here I have one vertical. Here I have one vertical. Here I have one vertical. All vertical I have to add. What is this vertical? Okay, leave this fundamental, it will go. What is this vertical amount is? This amount is S into e to the power C, that is the growth factor or interest rate 5%. C into 20 minus capital T. If I take here, that is deposited after T. If this is T, T is variable. Capital T is variable. What do you mean variable, variable, variable? Consider that why I give example. Consider I have four quadrant. This is 0 to 1, 1 to 2, 2 to 3, and 3 to 4, 4 quadrant. In the first quadrant, 7 is giving me 3 oranges. Second quadrant, 3 oranges. Third quadrant, 3 oranges. Fourth quadrant, 3 oranges. How many orange I have? 3 plus 3 plus 3 plus 3. That is 3 into 4. What about how many oranges I will have? This is x-axis. At any point x, then it will be 3 into x. Make sense? Okay, similarly, I have now in first quadrant I am receiving some orange, that is s into e to the power c bracket 20 minus capital T. The capital T is the beginning time. From second quadrant I am receiving similar s e to the power c in bracket 20 minus the this time, then this time, then this time. Consider that is same. I denote it as an abstract manner. What is your abstract manner? Means every gap I have a deposition of s into e to the power. Not it will grow like that. Everywhere I have a money as s into e to the power c in bracket 20 minus capital T. If I add for t, any t amount, like if this is x-axis for any x amount, any t amount, it will be multiplied by t. That much you will have. There are separate. This is what I say, dividing problem into n different parts. If someone is inserting s amount every year, then we are dividing problem into n different part where it will get matured after n year. Every year now I have separate computation. For first year duration computation is s to the power s into e to the power c in bracket 20 minus what is the delay he took to deposit the money, that plus. Now for second one, s into e to the power c in bracket 20 minus from beginning whatever delay he made, because after 20 years it will get mature. Now I have to add these for how many times? T times. If I calculate for capital T years, then capital T time, then it will become S into e to the power C in bracket 20 minus capital T into capital T, where first one is a function over capital T, function over capital T into T. It is a fit case of integral calculus. Now next T with capital T will become D capital T. So it will become the way I am saying I am getting 3 oranges every go. After x time, how much I will have? 3 into x, 3 into dx. 3 into x, 3 into dx. And dx will be from begin time to end time. Then I can get the net, where it will be s into e to the power c in bracket 20 minus capital T into t, because every one sector I get only once, into dt. Now e to the e to the power c, and in bracket t and 20 is the n number of years after which it will get matured, n minus n is 20. So I just can write n or a small t, that is 20, a small t minus capital T into d of capital T, where capital T limit is going from 0 to n number of times. So it is now s e to the power c in bracket n minus capital T dt, where integration is from 0 to n, because n times we are adding it. Okay, then this is called repeated addition to multiplication and multiplication to integral calculus, or we are dividing problem into n different parts and then we are adding it and bringing it to integral calculus. Someone can calculate it. It will come as s by c in bracket e to the power ct minus 1. If someone put the limit 0 to n, it will come like that. Means there are two sources now. dy by dt equal to cy plus s. dy by dt equal to cy plus s. Okay, if then there are two sources where money is growing. One source is the beginning amount. Someone deposited the beginning amount y0 and that is becoming bigger over the period of n years or 20 years. And second is someone is depositing S amount, first year, second year, third year, fourth year, and every S amount is becoming bigger, and it is. So there are two sources. One is outside source and one is inside source, that is the Y0. So inside source is growing like y0 into e to the power ct, and outside source is growing as s by c in bracket e to the power ct minus 1. At the end, the person who is withdrawing the money, he will add both the source and he will get the full money. So y equal to y0 e to the power ct plus s by c bracket e to the power ct minus 1. Okay, this is the one way that is not available in the book and we solved it. Can someone solve in another way? What is the distance of, if consider y as a amount, y is not rate of change in the amount, y is the net amount. How much a person is traveling from one location to another location? A person is traveling. Okay, a person is traveling. Then how much distance he is traveling after t time? Someone would ask. Someone is traveling. Yeah, I know someone is traveling. After t time, how many distance he has covered? What question someone will ask? If person A is asking to person B that there is a person who is walking and then after t time, how much distance he has covered? What this person will ask? What is his speed? What do you mean? Yeah, tell me his speed. He's walking, right? Yeah, he's walking. What is his speed? 10 kilometer per hour. For how many after how much time you want the distance he has traveled? After 2 hours, then 20 kilometers. Means if I want to calculate the net distance, if I have derivative of the distance, then I can integrate it through. If I want d, then I want to know d. If I know s, I'm sorry, I want to calculate s, that is the distance, then I will ask ds by dt. Can you tell me ds by dt? Actually, indirectly, he is asking ds by dt. If someone is saying how much distance that person has traveled over this duration of time, someone will ask what is his speed of the traveling. This much is the speed. Simply he multiplied the speed by the time. Actually, if someone is asking how much distance he has traveled, that is s, then indirectly he is asking what is ds by dt. Integration of ds by dt is s1. No. He did not do integration. He multiplied. Multiplication means integration only. ds by dt into t is multiplication. Then ds by dt integration is ds by dt into dt. The t will become dt. Actually, he is trying to calculate integration. Okay, understood. What do you want? I have dy by dt equal to cy plus s. Now there are two sources. Yeah, understand there are two sources. One source is cy, that is the y0 source, and another source is s, that is the external source. One is internal current and one is external current source in the LR circuit. One is the internal LR circuit. In temperature, in Newton's law, in Sir Newton's law, one is the internal temperature of this, and another is external temperature. There are two areas. Okay, here also two areas in the bank. One is the initial deposit from the customer, and one is someone external person is depositing money. Two sources are there, internal and external. Okay, I know, I understand. What you want? I want y. What is your formula? dy by dt equal to cy plus s. There are two sources. What you want? Y. Means you want distance. Yeah. I want the amount. Yeah, amount is distance. Amount. Can you tell me the The speed, what do you mean? I want the speed. What do you mean? I want interest rate. What you want interest rate? What do you mean by interest rate? I want velocity fact. I want dy by dt. Here dy by dt equal to cy plus s. No, I want different way. This is the straightforward. Now tell me, you have two sources. One source is y0. One source is y0. And one source is s. Okay, what is the rate of change of y? That is called interest. Yeah, that is interest. I want dy by dt. dy by dt means interest rate. Y means amount. Amount is changing per unit time. That is called velocity factor. If I want y, then if someone is giving me dy by dt, I can integrate it through. I have two sources. Okay, for these two sources, I want the distance, amount, y through this. Then I can add it after that. Okay, for this source, if I want y, then what is the velocity? So that I can integrate. What is the velocity? So that I can integrate. Velocity means interest. dy by dt means interest. Okay, what is the interest here? What is interest rate here? That is C in interest rate here. The interest rate here is C into Y0. Y0 is the beginning money. If I multiply it by C, that is the interest rate at the beginning. Now, interest rate will grow. The velocity graph of the, I want interest rate graph. Interest rate graph I want velocity graph. If this is the time, then I want velocity graph. So that if I integrate velocity graph, I get the distance. The area is the distance. Like that, if this is the time, then I want the interest graph. So that if I integrate the interest graph, I get the net amount. Okay, what is the beginning interest graph for the first source? That is C into Y0. Y is the initial amount. If I multiply by C, it becomes interest rate. Yeah, it becomes interest rate. What is interest rate graph over the time? That is the beginning interest rate C into Y0. Yeah, that is beginning interest rate. Tell me over the time what is your interest graph? That is C into Y0 into e to the power ct, because whatever you do, it will start growing with the e to the power ct. What is your interest rate graph? What is your velocity graph? If you want y, then y is amount. What is this? Y is distance. Then what is velocity graph of the y? There are two sources. One is y0 and one is, tell me for the y0. C into y0 is the interest at the beginning. Tell me interest graph. Then C into y0 into e to the power ct, that will be the interest graph for the first one. What about for the second one? Interest rate is S. We have told S unit is Y is money by time. So S itself is the interest rate. Yeah, S is interest rate. Then how S will grow? S into e to the power ct. Everything will be e to the power ct. Now I have two interest graph. One graph is for Y0, that is C Y0 e to the power ct, and another is S e to the power ct. If I integrate both and then add, then will I get the amount as per the formula of calculus? We will try it. This I thought of completing this, but it is long duration. It has happened. If I want to find any amount, then we try to get a velocity graph of that amount. And if I integrate the velocity graph, I get the amount. If I want velocity of something, then I try to get acceleration graph. Acceleration does not mean that someone is running. Acceleration can be in any way, current, voltage, anything. This is called acceleration factor. This is called velocity factor. There is a velocity factor comes in computation of area also. Where is velocity there? This is called velocity factor. If I get a velocity factor of y, then I can calculate y back with the integration. Now there are two velocity factors. One is C into Y0 e to the power ct. Another is S into e to the power ct. There are two sources of velocity factor. I have to integrate. This can be taken as assignment, and someone integrate, then he should get the net y. Okay, we will see. These are not available in any of the book. I can bet on this. Okay, please don't mind supporting us. +91 is the India country code. 9483160610 is the telephone. +91 is the India country code. 9483160610 is the telephone.